layer and 4 rectangular slots on the ground plane. Based on the theory and applications of transmission line, the electron length of short circuit stops is determined as 25.71 degrees. There is the problem at this structure of high-pass filter that has periodic spurities on the upper transition band. So how can I separate it? Each in four rectangular slots on the ground plane. The resonator enters the attenuation pole to separate the harmonic at 11.85 GHz. Frequency response has a very wide stop band at higher than 11.85 GHz. Okay, we see this figure. Figure 8 shows a photograph of practical ultra-wideband bandpass filter. Both the measured result and the simulated result are shown in Figure B. The ultra-wideband bandpass filter using hybrid microstrip defeated ground structure built on a FR4 substrate with relative permittivity epsilon r is 4.4 and the thickness is 0.8 millimeter. In simulation, it is found that the proposed ultra-wideband bandpass filter is in which the insertion loss is less than -3 dB and the return loss is below 20 dB in the pass band and has an ultra-wideband pass band of 3.1 to 10.6 GHz respectively. In measurement, it is found that the proposed ultra-wideband bandpass filter in which the insertion loss less than -3 dB, return loss is better than -15 dB in the pass band and has an ultra-wideband pass band of 3.1 to 10.6 GHz respectively. The out-of-band rejection level of -13 dB at high frequencies can be improved by properly designing both the DGS and the microstrip line for transmissions. Okay, this figure shows both simulated and the measured group delay. The measured group delay varies between 0.39 and 0.51 nanosecond, with a maximum variation of 0.12 nanosecond over its whole pass band. So, a new technique for designing microstrip defeated ground structure bandpass filters suitable for ultra-wideband wireless communications is proposed. A high selectivity ultra-wideband bandpass filter with a FBW of about 110% has been successfully demonstrated. The proposed ultra-wideband bandpass filter is designed with a composite structure by embedding a high-pass filter and a low-pass filter to each other. The high-pass filter is realized by 4 shunt-port wavelength short circuit stops, and the low-pass filter is realized by the microstrip defeated ground structure. Okay, the experimental filter showed low insertion loss, flat group delay, high selectivity, and excellent performance outside of the bandpass. This experimental filter is designed to have bandwidth complying with the ultra-wideband specifications. The major data show a good passband characteristic and a good agreement with the simulated results. That's all my presentation.
Open for questions.
Yeah, you introduce some rectangular defect ground structure. What's the typical length of the defect ground structure? The length.
The length.
Yeah.
Is wide or length?
Okay, so this. Yeah,
This.
longest dimension.
So it
No, I just want to load structure. My resonance say the frequency range about 14 to 20 kHz dimension. But this is WS, right? The W2.
W2.
Yeah, so,
This
yeah, this.
W2
So what's typical dimension for this?
dimension.
How many millimeters?
About
15 ton?
about
The
2.5.
width of the slot determine the characteristic impedance of the transmission lines. So when you plot the width, the characteristic impedance will be increased. So in the original turn to if you design the low-pass filter with the stated impedances designed in the original design, the slot transmission line will be produced the same characteristic impedance of the above design. So we try to properly design the slot width. Can you remember the slot width?
Can you go back to the slide you show the ground structure?
This
No, this one, the one before you show me many ground structure. Which dimension?
dimension.
No, this one. Go back to the one and the field.
The final design.
The final design, yeah, you call the dimension W2. Yeah, okay, this one. So what's the dimension for the W2?
2.554.
And what is the at 4, at 3?
At 3. Which at 3? This
L3.
Yeah, so those L1, L2, L3, what is the dimension for?
Slot 1, slot 2, slot 3, slot 4, the length.
Yeah, okay, you have width and length for each slot. So what's width, what's the typical length?
The widths are the same. W2 is 2.54.
2.5 millimeter. And L very small.
And yeah, and length I don't remember. About 1 millimeter. There.
Okay.
Yeah, I equivalent to a step impedance. So it more wide. Its impedance is more high. Yeah.
Alright, thank you.
Any other questions? Okay, thank you.